So immediately to my right is David Yaskowitz, who is basically an economist, socioeconomics, is that right, at Texas A&M, and I will be throwing questions to him about the economic and social human impact of the spill. To his left is Pete Peterson, who is a professor at University of North Carolina, and his claim to fame is following the Exxon Valdez spill for these many years, and it's obviously really interesting to compare what happened in 1989 up in Prince William Sound to what happened in the Gulf of Mexico last year. So I will turn to him for those questions. To his left is Ed Overton, who's an emeritus professor, although he's been working full-time, emeritus in quotes for sure, at Louisiana State University, studying the coastal environmental issues and so on. And last but not least is Russ Tunnell, who's also at Texas A&M, and he actually will bring us back to another huge spill in the Gulf of Mexico, Ixtoc 1 in 1979. So also very important lessons to learn from that as well. And I guess I want to throw my first question to Ed and say, okay, people aren't talking about oil anymore. Is it gone? What actually did happen to all that stuff that got spilled? 4.1 million barrels probably, plus another 800,000 that they managed to capture and bring ashore. Where'd it go? Do we still have to worry about it?
Next question.
You're not getting off that easy.
Of course, we're not yet a year out from the spill. It's been 6 months since the oil stopped going into the Gulf, and so there's a lot of debate on just where the oil is. But it looks like maybe 2/3 of the oil was dispersed naturally and with chemicals at depth. Only maybe 1/3 of the oil got to the surface, last estimates I'm hearing. The oil is eminently biodegradable. It is certainly being degraded very rapidly. Oil that reached the shoreline, particularly in the marshy shoreline, is still on the shoreline. I've heard some numbers like something on the order of 10,000 miles of marshy coastline were in harm's way from this spill. Something like 600 receives oiling, 100 to 150 heavily oiled. And those areas that were heavily oiled certainly are still heavily oiled today. Along the northern Gulf Panhandle, we're seeing tar balls. We went from heavily oiling during the summer when the active oil was coming into the Gulf to mostly tar balls. There's oil that's been incorporated down into the sandy sediments. It's tar mats. These things are breaking off. So you clean up tar balls, and the next day you go back, you clean up more tar balls, which is pretty similar to most oil spills. It's going to take a while. Hopefully, as we go, the amount of tar balls will be less. How quickly and how much oil is on the shorelines is another issue. You can't get into the marshy shorelines to do much remediation, so we basically have to let Mother Nature handle it.
And 2/3 under the surface of the water, is it still oil or what is it now?
Well, it was, remember, dispersed oil means that the droplets, in order to stay down at those depths, the droplet size needs to be something on the order of the diameter of a human hair or less, so 100 microns to 10 microns. So oil that's that small in diameter has an infinite rise time to the surface. Another way of saying that is it stays at depth. It disperses. Of course, it's got lots of surface area. It's being degraded by bacteria in the deep Gulf. Remember, the Gulf is an acclimated body to oil. 20 to 40 million gallons a year are estimated to seep into the Gulf. So you've got a highly acclimated body of water. And so it looks like as you get beyond the wellhead, something on the order of 10 to 20 kilometers, you lose the signal. So that current analytical capability doesn't seem to be able to track it much beyond 20 kilometers.
Is that because we didn't do a really good job of tracking it when it started to move away, or just because it's diluted to such an extent that you can't track it anyway?
Well, I think right now, of course, there's lots of studies that are going to be ongoing, but right now we're below the detection limits. In the detection limits for large quantities of water are in the low part per billion, part per trillion range. So we've lost the ability to detect it. Massive dilution, massive biodegradation. The oil that came ashore, there's no more oil floating offshore. There is stranded oil on the sandy beaches, and there's stranded oil on some heavily impacted areas, notably in the Louisiana Delta.
So Wes, this is a rerun of a movie that you saw in 1979, right? The Ixtoc-1 oil spill in the Gulf of Mexico. A shallower well, as I recall, but spilled for a longer period of time, a little bit less oil in total, but that was in some ways the baseline spill, if you want to put it, unfortunately, I guess, for the Gulf. What happened there? What happened to the oil out of Ixtoc-1?
Yeah, that's really the spill that we should be comparing to. The Ixtoc spill occurred about 50 miles offshore, the same, but only in about 160, 70 feet of water. It was in the very southern Gulf of Mexico. It was 140 million gallons of oil, and it spewed for almost 10 months. The difference being, of course, that the Deepwater Horizon kind of hung around in that calm time of the year, which was a good thing, except when the storms came through. And the Ixtoc spill moved forward slowly with the currents until it reached Texas in August and September of 1979. But then the northers started coming and some tropical storms came, and so the Deepwater Horizon spill covered maybe 400 miles of linear shoreline, not counting all the indentations, and the Ixtoc spill covered about 1,500 miles of shoreline, so a huge area of the southern Gulf was covered by all the shorelines.
And so what happened to that oil? How long did you see it, or do you still see it?
Yes, I was a young scientist back then. Ed and I both had the opportunity to study then, and I was aghast when I saw the oil coming our way from Mexico and then covering the Texas beaches, about 170 miles of the Texas beaches, 20 to 30 yards in width, and a half an inch to a foot in thickness on the Texas beaches in August of 1979. And so I was aghast. I thought everything was going to die and be gone. And yet, a couple of years later, it was hard for us to find anything. I monitored the sandy beaches from Texas all the way around the Yucatan in the summer of '80 and found some oil then, but a couple of years after that, could not find any. I was able to track it on the rocky shore areas where you can still find it today, just the asphalt end of it. That's why we use asphalt on our highways. It lasts a long time. I was also able to find it in the lagoon of a coral reef off Veracruz that I was taking a class to at the time, and so I repeatedly went there to study and just took the time to go measure this. And so when I went back last summer, out of much curiosity for lots of people, the tar mat that was on the leeward side of the island that used to be 60 or 70 yards in length and 5 to 10 yards in width and 12 to 15 inches in thickness was at that time last June when I went about 5 yards in diameter and about 1 to 2 inches in thickness. So I don't think it was having much of an effect except right where it was laying, but here 30 years later it was still there. The same on the rocky shores and the same in the mangrove areas north of Campeche.
What about coral reefs?
Well, I think we were fortunate during that time when the oil was hanging offshore to the east of the 25 reefs off the city of Veracruz. It didn't come in until a tropical storm pushed it in, and that elevated with the storm surge, and so the oil, we think, was carried over the top of the reefs and only hit the islands. And most of the islands there, about 15 of them, were just wrapped what looked like a black donut all the way around the island, from 10 to 15 yards in width, all the way around those islands.
Yeah, but what about biological effects of this? I mean, we heard so many early on, certainly in the BP spill, we were hearing that this is an enormous environmental catastrophe. What lessons can you draw from 1979 and tell us about what to expect?
One of the biggest lessons is that continuing ongoing research was not done. And that's my biggest message for today, is we need to keep doing it this time so we'll have the answers for the next time.
Gaps. Let me turn to Pete Peterson for a minute and ask about the other dramatic spill in U.S. waters in Prince William Sound in 1989, 10 years later, the Exxon Valdez, a very different kind of spill, all on the surface, a very different kind of environment, very cold. What tale of these two spills do you tell when people ask you to compare and contrast?
Well, that tale I told for a week, and then I stopped answering my phone. It was incredible how many people wanted to ask just that question, and that is, what did we learn from the Exxon Valdez oil spill that could help inform the process and the results after this one? I agree in many ways with Wes, and that is that Ixtoc-1 represents perhaps a better analog, except that it was so shallow. So it didn't invoke the sorts of processes that also occurred in the Deepwater Horizon spill. I think you're right. I tend to call this particular new spill a tale of two spills, because it had components that matched what you might call, euphemistically, the traditional spill, which is to say an oil that rises quickly to the surface.
Or starts at the surface.
Or starts at the surface in the case of tanker accidents and other things. And then, depending upon winds and currents and distance from shore, is transported into shore. So that the injuries biologically occur with organisms that live on the surface or use the surface skin of the sea. Those include, obviously, seabirds high on the list, and we all saw terrible images after the 1989 Exxon Valdez, and then revisited that, if it was a revisit, with images from the pelicans and others from the Gulf spill. So that's the first order. It affects sea turtles. Don't have them in Alaska, so they weren't at risk. And marine mammals on the surface, plus a variety of other things such as larvae, eggs, and early life stages of a variety of marine organisms as well. Then, if the currents are right and it comes to shore, then we have grounding of the oil on sensitive shoreline habitats. And we heard from Wes about two of them, sandy beaches and salt marshes. Those are the dominant two that we think about, but there are others like seagrass beds, oyster reef habitat, shallow subtidal habitats, and intertidal mudflats, for example. And so that's the traditional aspect of this spill. The non-traditional aspect is the tremendous emulsification and dispersion of the particles that occurred at depth. And what that did is to retain Wes's estimate. I can't dispute. I don't know that we'll ever know the exact number. We retained something like 2/3 of the mass of this oil beneath the surface. Also, we retained virtually all of the natural gas beneath the surface. And this was an oil and gas release. And so we need to think of that when we think of mass balance in the system and when we think of microbial production that is stimulated by the fixed carbon. It's something like what we know in the shallow water Gulf, or could be, in eutrophication, although it didn't appear to get to this degree in the deeper Gulf waters as judged by measurements of dissolved oxygen.
Yeah, the dissolved oxygen, I guess, went down somewhat, but not very dramatically. And the statistics I've heard about how much methane were in there, it's someplace between 30 and 40% of the hydrocarbons came out in the form of methane. Ed is nodding in agreement about that. And let me back up a little bit, Pete, before we pass the mic, and ask you about to look a little bit at the megafauna that is obviously the easiest thing to sort of have an immediate emotional reaction to. And certainly in Prince William Sound, if I remember correctly, it was like 250,000 seabirds oiled and killed. And here,
tremendous numbers.
Yeah, and here, apparently a much smaller number. Does that sound right to you? 2,500, a couple thousand? And
here's what you've got to be aware of. We are working off of pieces of information that are released. And I think the information release from some of the surveys has probably exceeded what we had at this stage in the Exxon Valdez oil spill. In both cases, the litigation-sensitive nature of that information has meant that we haven't gotten it very quickly. But I think we've gotten it more quickly this time, especially on various, for example, NOAA websites. And so what we know is how many oiled dead birds, for example, those are our megafauna here of most interest, have been collected. Okay, so for example, it's a fair number of gulls. They lead the pack. Brown pelicans are up there. Black skimmers, a variety of others, some terns and other. I mean, the bird list is long of dead birds. So that's the most obvious. But here's where we can make the mistake, and where I'm happy to correct you. You'll be back correcting me in a minute. And that is that those are how many have been collected. Okay, so you're a bird, you die, you're not, immediately taken to the cemetery and have a proper ceremony. Here's what happens. Maybe you're collected by the scientists and others that are out there. Maybe you sink and you're never seen again. Maybe you're transported out in a current in a direction that carries you away from where anyone is looking, or maybe you're eaten by sharks. There's a wonderful study that came out just recently that looked at tiger shark guts around oil platforms outside of Mobile Bay. And these were tiger sharks in an area where there wasn't a great deal of oil at the time, but these were during April, during the passerine bird migration season, when birds are migrating up from Mexico, South America, coming back into North America. These are some of the birds that are really in trouble, the ones we love and feed in our backyards. And these tiger sharks were absolutely loaded in their guts with feathers of passerine birds. The interpretation is that as they approach the coast, they migrate at night, so you need to know that. The lights on these platforms disorient. So they circle the platforms until they get too tired, then they crash to sea or rest in the sea, and that becomes their final resting place.
Yeah. Okay.
And so here's the point. Those numbers that we have not been corrected by the transport models and the models for consumption by scavengers. And when they are, we'll have a different impression of how many birds actually died.
Yeah, well, that's why I asked. It's good to know, so let's keep an eye on that. But let's not forget this is a tremendous human impact beyond the 11 men who were actually killed in the sinking of the Deepwater Horizon. And I want you to give us a flavor for what that means in terms of, let's just start with some basics about the economics of the Gulf of Mexico. Right. Where does oil and gas fit in, and how much was the entire economic system disrupted?
There's really a tale of two economies here. There's kind of the traditional market economy, and I'll talk to that about in a moment. And there's also what I would call nature's economy. So we did a study a few years ago that looked at the productive value of the Gulf of Mexico, and it took into account oil and gas production, tourism, fisheries, and shipping or port operations. And we looked at that in the United States and Mexico, and unfortunately we didn't have the information for Cuba. What we found in this productive value, and this is the extractive resources, what we found is that that value per year was about $294 billion, just in those four sectors, or Peru. So it's just in those four sectors, it's very, very productive, very important economic engine. On the nature economy side, those goods and services that aren't taken into account in the market, there's a tremendous impact on human well-being. For example, if you look at salt marsh, two services that are provided there, such as storm protection, disturbance regulation, and waste regulation or filtration, what we found that if you add those two together, each acre of salt marsh in the Mississippi Delta and along the Gulf Coast would provide about $2,400 worth of benefits per year. Now, what we did also was we calculated, okay, what if 500,000 acres were to be impacted by this spill? Well, that would put those two services only at $1.2 billion. So that's a tremendous benefit that we derive by just having to take care of that resource.
Mm-hmm. And how much of that has been disrupted?
Well, I mean, I think, the other panelists could probably get a better sense of how much has been disrupted. We know that the marsh hasn't been as severely impacted as was once thought, that the roots haven't been compromised, and so growth has come back, but I'm sure these other panelists could talk to that better.
But overall, in terms of you obviously lost a year of fisheries. You slowed down the oil and gas, but certainly didn't stop it for a year. Yeah. Shipping, I guess they had to dodge flotillas of skimmers and so on.
But that was, the biggest impacts obviously had come in fisheries and come in tourism. And also oil and gas. There was some questions about the moratorium. What would it do to the economy? What would it do to the economic engines of southern Louisiana and Texas and Alabama and Mississippi? Actually, it was projected that maybe 8,000 to 12,000 people would be put out of work during the moratorium, but a recent study by GNO Inc., which is the Greater New Orleans Incorporated, which is the economic community there, found that the anecdotal evidence just isn't there. I mean, there was some impact, but a lot of these firms kept people working, dug into their savings, but found that if we released these people, it was going to be more expensive to bring them back. So the moratorium didn't have the impact that people were projecting.
And tourism obviously took a big hit, but it might come back. Let me turn back to Wes and ask about fisheries, because obviously it could have been worse if, with the amount of marshland that was hit and so on, but what kind of impact do you expect to see on fisheries? I mean, there's all this oil in the water, oil is toxic, there's dispersant is toxic, and, any clues or any way of sort of gauging what that's going to look like?
Well, if we could look back at the Ixtoc spill as a starter, and then I'll come to the present spill. A colleague in Mexico at the University of Mexico in Mexico City, Luis Soto, had been studying the shrimp fishery in Campeche in the southeastern Gulf before the Ixtoc spill, and he said that after 2 years it was back to what it was before the Ixtoc spill.
Just 2 years. Yeah.
There aren't many examples anywhere for us to look at to tell for sure. In the Persian Gulf spill, there was a complete collapse of the shrimp fishery there. So there are different factors in each place to consider. If we look in the northern Gulf, the groups, fishery groups that people care about, the shrimp, the crabs, the oysters, and the finfish as a large lump, huge amounts come from the Gulf of Mexico. Over 70% of the shrimp for the whole nation come from the Gulf. A little under 70% of all the oysters for the nation come from the Gulf of Mexico. So these are huge populations that are fished, and each are a little bit different. The shrimp, maybe in the Ixtoc case, is the fact that generally in that case the oil was on the surface, the shrimp live on the bottom. That's a pretty simplistic way of looking at it, but that may be the case. They do have floating eggs, and larvae actually move up and down in the water column that could have moved through the dispersant. The marshes that Ed mentioned a while ago, the edge of the marshes is the best place for the juvenile blue crabs and the shrimp to grow up, so it's really an important area, and some of that was impacted. So we may see a percentage reduction in fisheries, say, this year, but I wouldn't be surprised if the fisheries was pretty much back on a similar trend as what it was before, partly because of the closures, some indications from Dauphin Island Sea Lab and sampling that was done there. Their numbers show huge biomass that was collected in shrimp trawls, 4 times the shrimp numbers that they'd collected before, partly because nobody else was out there shrimping. And so that should help the...
So the one-year hiatus essentially in shrimping might actually
yes, and
reduce
with other things also.
the fishing pressure, right? I'm sorry?
Yes, with other things also, not just the shrimp, but because this is a biologist interpretation, not a geospatial scientist now, about 5% of the entire Gulf of Mexico, if you look at kind of the daily logs on GeoPlatform from NOAA, about 5% of the total Gulf was impacted by the oil. Maybe 10% of the northern Gulf if we're looking at U.S. waters. And so these species we're talking about live all over the place. And so they'll reproduce in these other places that weren't impacted and fill in the gap once the perturbation is gone. And so only time will let us know whether or not that's the case. We may have a little bit of a down year this year, but then back up next year. The oysters produce huge quantities of eggs. They're all over the waters. The controlling factor there is the substrate to land on. Most of the northern Gulf is soft sediment. Yet the oyster reefs are hugely productive, primarily in Louisiana, although they're in all the states. So it's a mixed bag.
Ed, did you want to add something to that? And then I'll ask Pete.
Yeah, we know that the oil was heavily weathered. It was dispersed at depth. A lot of it stayed down there. A lot of it that came up to the surface in tiny droplets, which basically was extracted by the water column. So in the Exxon Valdez, the release was at the surface. There was a black tide, and a black tide came ashore on a rocky shoreline with large tidal fluxes. So fresh oil onshore, buried in the intertidal areas in there. That doesn't appear to happen significantly in this spill, thank God. Weathered oil got to the surface. It meandered around because there were no strong weather fronts and ocean currents that would bring it in. So by the time patches of shoreline were oiled, little eddies broke off, but it was a mousse. It was heavily weathered, and the lighter, more water-soluble components had weathered off. Now, this means that you don't have a lot of the components that can dissolve down in the water column and have as big an impact as you would have from fresh oil. Now, I hope I'm not being optimistic. I'm a citizen of the Gulf, and I certainly want the Gulf to come back. So I will add that bias that I'm pulling for the Gulf, but we need to be careful. But weathered oil came ashore. Weathered oil was mostly on the surface, and weathered oil is significantly less toxic and dangerous than heavy. It has a smothering effect. It has an oxygen depletion effect, but a lot of the toxic effect due to the solubility of these compounds and the fact that it was offshore hot water was lost by the time the marshes were impacted. So knock on wood, I'm optimistic that some of the impacts are not going to be as dramatic as we're seeing, for instance, in Alaska, where there's still impacts 20 years later.
Yeah, Pete, would you like to tell us about that? And do you share the optimism of the gentleman to your left?
No.
What did I tell you?
No, I just wanted to add a couple things. First, just relative to the fate of the oil, we dodged a huge bullet in this. I hope people recognize. If you look at this time of the year, you're usually getting very good onshore winds. Bringing that in, it's gotten to that season where we should have had transport of that oil relatively rapidly to the Gulf shorelines. In addition, the oil should have been caught up into the loop current and sent on over to West Florida and the Florida Keys in some form. We dodged both of those bullets in this spill, so that's just one of the, I think we all know that, but I wanted to add to that. Then I wanted to add a bit to the fisheries story that Wes was saying. Shrimp are the weeds of the system. So shrimp are out there, a couple-year lifespan, and so they can respond quickly and return readily. But we do have a group of fishes that has very long lifetimes and are a consistent management problem and are plaguing marine fisheries and state fisheries as well. The hard-bottom reef fishes, the snapper grouper complex, we like to call it. And those fishes are ones that will not come back readily if they were impacted. Now, I don't know if they were impacted or not, but I wanted to raise that the life history differences among organisms will lead to great differences in their responses over the long term. And then finally, the fate of the oil. There's one additional part of this that does relate some to the Exxon Valdez and to issues that we discovered there about persistence of even weathered oil and the consequences that can have over a very long period of time. And that is that there is oil deposited on the soft sediment seafloor over some substantial area. How far and what the area is not known. It's millimeters to centimeters of a black deposit, high in total petroleum hydrocarbons, high in total PAHs. In addition, there's a section downslope of the well that has an asphaltene cover, which won't degrade very readily, if at all. But it's this cover over the soft sediment bottom, and some of that cover has also extended to the deep water corals and some of the hard surface bottom in the system. So that is going to represent a much more long-lasting consequence to the system, and in particular in the soft sediments. What we've learned through recent work of Bufadel and colleagues in Alaska about some of the persistent oil and persistent toxicity is that oil that is sequestered away from oxygen and away from nutrients, which mostly means nitrate, will be very slow to weather and will stay persistent. So if that's a system also where physical or biological activity re-exposes key organisms, it can then have the effect, as it had in Alaska, of a decade and longer of exposure of things like sea ducks in Alaska, sea otters, and in our system in the Gulf, deep sea things that we hardly even know about, where the census of sea life, and Ron O'Dore had better tell us great things about. So that's the part of the oil that I think, to me, continues to be a great concern. There also is concern in the marshes and the soft sediments near shore, where that kind of thing can happen too, and where oil can be buried. And I mean, after all, these great reservoirs of oil are not being degraded by bacteria and are out of touch with oxygen and nutrients as well. Of course, it's a little bit different to talk about something that's many kilometers deep and enclosed
mud line, yeah.
enclosed in salt and basalt and other things.